Hello, we're now in the next lesson of this web search unit on the fundamental principles behind web search. And we start off with our famous DIKW. DIKW is pretty important. People should all know about DIKW. So we need to do this hierarchical mapping of data as it goes higher up the chain. So data is raw web pages, information is the result of query or documents views as a collection of insights, knowledge is the result of processing query results by the user, synthesis is taking many such actions by a lot of users, and that goes into wisdom of a field. And data is, you can sometimes divide data into raw data and data, and you can have various stages in the information. There's always a pipeline, starting with the rawest data and ending up with the most refined knowledge. Oh, sorry, I should say refined wisdom. So here we have a document. Here it's just a newspaper on this picture, on this web slide from this nice German slides I found on the web. So we have a document which is a coherent passage of free text. It's also going to end up being a web page, and it may or may not be coherent. There are many web pages which are pretty incoherent, especially if they're social media web pages. Free text is just standard text. I don't think it's free as opposed to put in prison, but and it has email, social media, blogging, blah, 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 dictionaries, scientific articles, newspaper articles. Google News, for instance, has all newspaper articles. Google Scholar has scientific articles. I'm always going to the web to see how to spell things, I just put dictionary in my search, and it goes to dictionaries and tells me how to spell things. And gives me synonyms and antonyms and all sorts of things I might need for a given word. It's very helpful. So, of course, documents are arranged in groups, which are called the corpus, and all documents in a group are usually similar, although they may just happen to be all documents in a given place. And the Medline collection of life biology, life science documents is one. Google News has a set of articles, which was a document collection. And of course, the web has the world's largest collection of documents. That's the largest corpus, almost by definition. So we want to find out what the user really wants. Sometimes they just want, when I go to the web and try to how to spell anti-disestablishment or whatever I'm trying to spell, then I just want that word and to know whether, in fact, actually the current search are pretty good. If you misspell the search term, it will actually tell you how to spell it, because it finds automatically there are no matches to misspelled words. But more normally, and actually a bigger challenge, is not how to spell a word when you just want the word back, possibly in a dictionary, but you want to know the essence. When I type, how do I escape from this mess? I want to know how to get out of the stress of modern life. So that's a hidden cognitive state that I'm agitated and want to escape. And so the information needed is general information about how to get out of a mess. And it's pretty ill defined, and it's not so trivial, and it's not, the answer is not unique, but some of them are precise. Capital of Uganda is pretty precise, although I can't actually tell you what it is. We will, you're probably pretty hard to find out on the web what McDonald's meat actually is, because you will get various answers to that statement. And as we showed when we did the section on cloud computing, there are endless definitions of cloud computing, and you can also get different definitions from, if you look at the software, you get one definition, the hardware, a different definition. If you look at the way users use it and the way users feel about it and things like that, these are all different feelings about cloud computing. But still, when you type cloud computing, you'll probably have one of these ill-defined goals of finding out about that subject. So, a critical idea here is the so-called bag of words, which is sort of related to this concept of the vector space, because documents live in the space of which is actually got 1,000,000 dimensions in English, which has got the number, which has represented by words, which the document could have, and we can either view it as a bag, as we have here, a nice bag with full of words, or we can think of it as a vector, which has got the components, which are the words in the language we're dealing with. Let's say if it's English, we know it's 1,000,000 words, and then you just put an entry in that vector. If there was that word is present, you just leave it blank. It's not, well, it's 0. It's 0 if that word is not present, and it's 23 if that word is present 23 times. So that's the vocabulary. That thing that's 1,000,000 is the vocabulary. It's the set of all words containing in the documents collection, which, say, for the complete English language corpus is around 1,000,000, and each document is represented by a bag of the words it contains. So here we take the document. That's one small step for man, a giant leap for mankind, and we break it up into a bunch of words, most of which occur once, whereas 4 and A, which are not very interesting, so-called stop words, which occur a couple of times. So this is not a very interesting sentence with a very rich bag of words structure. So here we have this nice vector model, and we have here a couple of sentences and a different decomposition into these index terms or vocabulary around here. So that appears in this sentence but not in that sentence. Small occurs in both of them. 4 occurs twice here and 0 here, and so on. A is twice at the top, once at the bottom, and so on. So these are just different vectors in the space of words. Or you can just say it's a bag which has the words that are in the document sitting there. In order to get more sophisticated search, in the simplest bag of words, you don't record the position of the word in the document. In the real world, with state-of-the-art search engine, you probably record the position because this allows you to search for phrases more effectively. So these are improvements of the bag of words model. As I pointed out, we want to add, sometimes we want phrases like the the White House is a phrase, and you want White and House together is important. The fact that they're next to each other. You're not so interested in the many documents that have White on line 1 and House on line 55. You want the document to have White followed by House. So there is some technology which I think most people would invent if they had to invent it to cope with phrases, and we also will discuss you have to clean up all these words and convert them into canonical form. In the next, not in this unit, but in the next unit, we will go into the most important Internet-specific feature, which is the use of links and anchor text and search history and context, what my Google Mail had just told me and things like that. So the web is notable for having special features, of which links are the most remarkable. That's what made Google its few $100 billion, which is made it because they recognized for the first time. Actually, they weren't the first person to think links were important. They were probably the first people to do links in a very powerful fashion using the so-called PageRank algorithm, which was particularly effective. So that ends the general discussion of the bag of words. And now we will discuss, the next lesson will discuss the components of information retrieval and web search.